So hello everyone, welcome and welcome back to my YouTube channel. So today we are going to discuss about science reasoning section basically. So this is basically we are going to look at science reasoning, and this is from the past paper of AKU, and here one passage is given, and this passage basically after reading this complete passage and this chart box we'll be able to answer these four questions: question 1, 2 and 3 and 4. So yeah, let's get started. First of all, we'll be going to find some of the important points from this passage which will definitely help us to solve the questions properly. Okay, so first of all, they're asking scientists theorize the release of X-ray by distant stars and the amount of distortion or blending the X-ray. So indoor that they travel in the solar system and help to indicate the presence of planet orbiting star. The distortion of X-ray would be caused. Okay, so here the first line is the distortion of X-ray will be caused by gravitational pull. So this is we can say that the distortion of X-ray can be caused by some of the physical we can say forces too. So physical force is gravitational pull too. So it could be caused by the physical. Let me write here. Physical forces. Okay. So after that, the another point could be yes, specifically high blending. So high blending in these rays would indicate the presence of large planets, while the low blending would likely signify the presence of smaller planets. So here we do have high blending and low blending. So when we do have high blending, it indicates basically the high the larger planets. However, if we do have small blending, so it indicates the smaller planets, right? After that, in addition to, let me change the color. Okay. In addition to determine whether or not the planet are circling a distant star, the amount of X-ray distortion can be determined by planet orbital pattern. A circular orbit produce increasing or decreasing distortion of the same level. For instance, if the star X-ray are bent 1 meter on the first day, 2 meter on the fourth day, 4 meter on the seventh day, and so on, it indicates the circular orbit. So here you can see there is the increasing order, like the X-ray are bent 1 meter on first day, then we do have 4 meter on second day. After that there is basically 2 meters on the second day and 4 meters on the third day. So here you can see this is the increasing order, and they said this is the circular orbit. Whenever we do have X-ray distortion happen in this way, that is circular orbit, means that revolve in the circular orbits. But if however the pattern of blending is random, अगर हमारे पास पैटर्न ब्लेंडिंग का क्या है, रैंडम है, as in the blending of 5 meter on the first day. For example, blending we do have 5 meter on first day, then they do say 3 meter on second day and 0 meter on third day. So 3 meter on second day and 0 on third day. So here you can see here is basically decreasing order. This is okay. After that they are asking the 7 meter on fourth day too. So 7th meter on fourth day. So this is not decreasing, this is basically in the random direction. This is in the random process. So they form the elliptical orbital. Okay, so here we got that if we do have sequences properly, so they follow orbital circular orbit, and if the sequence is not following the clear path, that is random or non-linear, so that form the elliptical orbitals, right? So here you can see further, if the path of x-ray are not bent in any way, if अगर हमारे पास जो x-ray का path है वो किसी भी direction में bent नहीं हुआ, it is assumed that stars lack any planet. ये assume किया जाता है कि stars के पास planet की we can say decrease हो गए या lack हो गया planets का. So, okay, so this is basically the X-ray distortion diagram is given. Here you can see star 1. Star 1 on day 1 is 1 meter, then 1.75, then 2.50, and then 3.25. So what you can identify from this table, here you can see this in the star 1 there's an increasing order, and they basically this is the increasing order 1, then 1.75, then 2.50, and then 3.25. Okay, so this is what this is the increasing order. This means they follow the circular orbital. After that, in the star 2, the complete is 0, 0, 0, 0. So this means star 2 has lack of planets because there is no X-ray bend or distortion. Then star 3 is 8, 4, 2, and 1. So this is basically complete and decreasing. So this is also the circular. However, circular orbit is increasing linearly or decreasing. This is decreasing linearly. So this means star 3 is likely to orbit at least one large planet. It will orbit around one large planet because it is decreasing randomly. Then star 4, here you can see 0.20, 1.1, 0 point and 0 point. So this is not increasing or decreasing linearly, however it is random. It is random, so it basically have the elliptical orbital. So now what the question first ask about, the question 1 is which of the following statement is the best supported by the information in the passage, means which is the best statement which is support this information. So we do see that star 3 is likely to orbit at least one large planet. Yes, because this is decreasing in the linear motion. So A is the correct option, but we will look into B, C, and D options too. Star 4 has the circular orbit. However, you can see in the star 4 there is 0.20, then 1.10, sorry 10, 0.11, and 0.11. So this is not basically the proper decreasing order. This is the random, and we know the random form the elliptical, not orbital. So this is elliptical, not orbital. That's why B is wrong. Then star 1 is elliptical orbital. So here star 1 is 1, 1.75, 2.50, and 3.25. So this is basically the randomly increasing, not randomly increasing, but linearly this is increasing. So if linearly increasing, they follow circular, not elliptical. So it follows circular, not elliptical. So this is also the wrong option. And star 2 is likely orbited by several small planets. So star 2 is no any bent. There is the lack of planets, so this is also wrong. So our correct option will be A. Now moving towards the second question. In the second question, they ask about if the X-ray distortion were observed. Wait, yes, if X-ray distortion were observed for an additional 3 days. If for the more 3 days, additional 3 days ज़्यादा अगर हमें एक्सरे डिस्टॉर्शन ऑब्जर्व करनी है, one could predict that path of X-ray produced by the star on the day 13. So day 13 पे उसका path कितना होगा? Not day 17, sorry, day 13. So if we can basically determine from this table, so here you can see first is 0.75, then B is 1, and then C is 3.75, then 4. So there is basically increase of what? There is basically, okay, not this option, but we will be assuming some of the options. We will determine that, for suppose if the we can say distortion of x-rays increased by 0.75. Okay, so if we do ask on the day 13th, the day 13 the distortion will be 1.00 meter. So B will be the correct option here. Then question number 3 is basically according to this information in the passage, which of the following assumption could be true? So since in here we do say x-ray are affected by certain physical forces, yes of course, because I told you x-ray are affected by gravitational pull too, and that is the physical force. Then x-ray are simply bit of energy and therefore unaffected, sorry these were affected by physical forces. Then third option is planets with elliptical orbit are moved commonly with planet with circular, no. The presence of planet orbital Oscar can detect using X-ray. Sorry. So A will be the correct option here. Then question number 4, which is the last question of this passage. Here they ask about based on the information in the passage, which of the following star most likely has at least one planet with an elliptical orbit. इनमें से बताओ कौन सा एक ऐसा प्लेनेट है जिसके पास इलिप्टिकल ऑर्बिटल है. So here the correct option is basically star 4. Star 4 has the elliptical orbital. Likely it is elliptical cause it is increasing 0.2, then 1.10, 0.1 and 0.11, so it is elliptical. So these were the science reasoning passage 1 we did, and I hope you got something new and you got how to solve the passages and these type of questions. So yeah, till that, bye bye. We'll do some more questions in next video.